Welcome to skill number 23. I can solve systems of equations in 3 dimensions algebraically. The process of solving a system of equations is a 5-step process when you're dealing with 3 variables. The first step is that we take equation 1 and 2 and we cancel one variable with that. The second step is we take equation 1 and 3 and we're going to cancel the same variable. The third step, we use substitution or elimination with the equations generated in step 1 and step 2. This gives us 2 variables solved, which we can plug into the equation, one of our original 3 equations, to find the third variable. And then the last step, we check that our final solution is consistent with all 3 equations. Alright, so here we have a variable, or a system of 3 variable equations, and step 1 says use elimination with equation 1 and 2 to cancel one variable. So we have 3x plus 2y minus z equals 12, and we have 2x plus 3y plus z equals 33. If we use elimination, a very simple variable to eliminate in this case would be z, and we'll do that by adding our 2 equations, giving us 5x plus 5y equals 45. And this will be equation number 4, which we will use in step 3. Alright. Step number 2 asks us to use elimination with equation number 1 and equation number 3 to cancel the same variable. And as you saw in step 1, we canceled the variable z. Now if we used elimination here, notice our z's are not matching, i.e. they do not have the same coefficient in front. So in order to make them have the same coefficient, I'm going to multiply the first equation by 2. That gives me the equation 6x plus 4y minus 2z equals 24. And then equation number 3, we can just carry down 2x minus y plus 2z equals 8. When we use elimination, we're going to add these 2 equations together, and we get 8x plus 3y equals 32. And this is equation number 5. Alright, step 3 asks us to use substitution or elimination with equations 4 and 5. And just to recap, number 4 was 5x plus 5y equals 45, and the fifth equation was, that was 4. The fifth equation was 8x plus 3y equals 32. If you notice, we don't have consistent leading coefficients here, so if we want to use elimination on these 2 equations, we're going to have to multiply. I will choose to multiply the top equation by 3, and I'm going to multiply the bottom one by 5. What that does for us is it makes us have 15x plus 15y equals 135, and the bottom equation gives us 40x plus 15y is equal to 160. Now that our y terms are consistent, we can add or subtract the equations. And since they're both positive, let's subtract them to cancel the y. And we get negative 25x is equal to negative 25. which means x is equal to 1. We have just solved our first variable. X is equal to 1. If we plug that into one of our top two equations, one of these two equations, what we'll wind up having is 5 times 1 plus 5y is equal to 45. 5 plus 5y is 45. 5y is 40, and we get y is equal to 8. Now we've solved for two of our variables. We are almost there. Step 4 asks us to plug these solved variables, and we found that x was 1 and y was 8 into one of the original three equations. I'm going to plug them into the first equation. So we get 3 times 1 plus 2 times 8 minus z equals 12. 3 plus 16 minus z equals 12. And with a little calculation, we wind up arriving at z equals 7. This tells us that our final solution is 1, 8, 7. X equals 1, y equals 8, and z equals 7. But step 5, we better check our solution to make sure that it's consistent with the other two equations. We've already checked it with the first equation, so in step 5 we're going to check it with the second and third equation. So we have these three equations, and we've checked it with this equation, and so we're going to check it with the remaining two equations. So 2 times 1 plus 3 times 8 plus 7 is equal to 2 plus 24 plus 7, which is equal to 33. And that checks out. And then we check with the final equation, 2 times 1 minus 8 plus 2 times 7 is equal to 2 minus 8 plus 14, which is equal to 8. And that checks out. So that concludes our lesson on skill number 23. Our solution was 187, which means the variables x, y, z, if they were 1, 8, 7, would satisfy all three of the original equations to our system.